Welcome to the Unit 2 Lesson 12 video. Go ahead, pause the video, and work through these first two activities. So activity 1, you're figuring out what that variable needs to equal. In activity 2, you are finding the algebraic statement that translates from that word statement. Alright, so go ahead, pause the video, work these things out, unpause it, and then see how you did. So, number 1, in activity 1, 9 plus 8 is 17. We've got 16 minus 7 is 9. 8 times 9 is 72. 56 divided by 8 is 7. 6 plus, well, if you want to break things down a little bit, I usually like to try to break till 10. But we get 7 for this one. 6 plus 4 is 10. 3 more gives you the 13. 4 and 3 make 7. And then 14 minus 7 equals 7. Activity 2, Amy is 5 years older than Bob. If M represents Amy's age, Amy is the older one, and X represents Bob's age. If I take Amy's age minus 5, I get Bob's age. This would be 5 times as old, which only happens once. If one person's 5 and the other person's 1, then it's going to be different the rest of the way. This says if you had Bob's age and he was 5 years younger, then he would be Amy, but Amy is the oldest, so that doesn't work. Number 2, there are 5 times as many students as teachers. If Z represents the number of students and B represents the number of teachers, I'm going to have 5 times the number of teachers is the number of students. Okay, there are 5 times as many that makes us want to kind of switch those variables around from what might make the most sense immediately. Number 3, there are 3 more dogs than cats at the kennel. If D represents the number of dogs and C represents the number of cats, since there are 3 more dogs, that means I'm going to have 3 plus the number of cats equals the number of dogs. So today we're going to do the reverse of what we did in Lesson 11. We're going to translate from algebraic statements into word statements. So as an Algebra 1 teacher, I'm going to tell you that some of these things we're going to go through are great steps for just kind of clarifying in your mind if it kind of made sense, but it's not always going to be how you are going to do these problems. So we're starting with A equals 5 times B. So the first thing we want to do is figure out what's happening. Okay, we know that we are multiplying. Okay, that's the first thing we need to figure out. Find out where we're multiplying, if we're adding, subtracting, dividing, whatever the case may be. Then it says, so this one says we have a number A is equal to 5 times a number B. So they use the words one number is 5 times another number. I honestly will prefer one number A, or a number A, is 5 times another number B, to make sure that we know that they are different numbers. A and B are different letters, so they have to be different numbers. Then they want you to think of a situation where this statement might apply. So where could there be one number is 5 times another number? They can be as normal as you can think of, kind of like that number of students, number of teachers problem, or they can be as abstract as you want them to be. So like they use, we're going to assign variables to the number of objects that can be counted. So we're going to talk about cards. A is going to represent the number of stars on a card, and B is going to represent the number of stars on a different card. Okay, this is not an example that I personally would come up with, but if that's how your brain works, absolutely go for it. So we're still looking at this statement right there. If I've decided that A is the number of stars on card A and B is the number of stars on card B, think of a couple of numbers that might work, that might make this thing true. So if I said, hey, there's 2 stars on card B, how many stars would be on card A? Well, 5 times 2 is 10, so there'd be 10 stars on card A. I need to double check, does that actually kind of fit in with what works there? And it does. And if you're like, I'm not so sure, draw it out. Okay, use a picture to see if that's true. So if I drew 10 stars on card A, every time I drew 5, so I drew these first 5, then I draw a star over here, then those 5, and a star over there. See if your numbers make sense. You could try different numbers, different examples. You could say, what if card B had 6? Well, then this one should have 30. You can do whatever numbers you want to because that's not your final answer. What they want you to do is to write a word statement that describes your picture. Now, this is where, as an Algebra 1 teacher, I'm going to be a little bit wary of this, because it says there are 5 times as many stars on card A as there are on card B. If you are just given this statement, A equals 5 times B, with no other context, you can't really say this and be 100% certain, because maybe this A equals 5 times B had nothing to do with cards. This is just an example of a statement that works for here. If I want the example, it is as simple as a number A is 5 times the number B. This is the statement that works for here. This is an example of a statement that works for here. The benefit of the example is we get a little bit more concrete, and we can kind of visualize if this thing makes sense. So now we've got a new one, m equals k plus 3. So maybe we want to think of m as Enrico's age and k as Carmen's age. Then we could say that since we have k plus 3, we could say Enrico is 3 years older than Carmen. Okay, Enrico's age is equal to Carmen's age plus 3. That is an example. Another one is maybe we're thinking about a school bus. To go to every time the school bus goes to another school for a game, there needs to be 3 adults. How many people are on the bus? If we let m equal the number of people on the bus, and k is the number of players on the bus, okay, the number of people on the bus is equal to 3 more than the number of players. Or the total number of people on the bus is the number of players plus 3 adults. Those are all examples that fit this expression, this equation. But they don't have to be identical. So when we go through these problems here in a little bit, your answers might be different than mine because you get to come up with your situations. But reversing a process helps us gain flexibility in solving problems. Being able to go from an algebraic statement to a word statement is just as valuable as going the other way around. So we've got 3 practice problems here. Name the values that each variable represents, then write a word sentence that represents each algebraic sentence. Your answers are more than likely going to be different than mine, so go ahead and try to do all 3, then come back and see if yours are somewhat similar to mine. Realistically, as long as they make sense with numbers, if you plugged in numbers for each variable and it worked out, that would be fine. So for number 1, I'm going to say let A represent the number of apples and B represent the number of bananas. My word statement is the combined number of apples and bananas, or the total number of apples and bananas is 12. Or there are 12 fruits, or something like that. For number 2, we've got 4 times C equals D. I'm going to say let C represent the number of cats and D represent the number of dogs. Now, 4 times C tells me C is the smaller number. So there are 4 times as many dogs as cats. The hard part here is making sure you have 4 times with the right thing. I could write this a different way. I'm going to write the exact same situation with a different sentence. I'm going to say 4 times the number of cats is the number of dogs. Exact same situation, a different sentence. 4 times goes with, in words, goes with the other variable is what it looks like. But you have to think of the context. There are 4 times as many, means 4 times the thing that they're compared to at the end, or 4 times the number of cats. That's 4 times the number of cats straight away. And we've got n minus 5 equals m. Let n represent the number of, I'm going to go with pencils. And m represents the number of erasers. Okay, my logic here is I know that n minus 5 equals m, and I know that there are pencils that have erasers and pencils that don't. So I know there's probably less erasers than pencils. So the number of pencils minus 5 is the number of erasers. That would work. You could say there are 5 less erasers than pencils. That would also work. Okay, so for all of these, just go ahead, plug a couple numbers in for your variables. So like if I said 7 apples and 5 bananas, that adds up to 12. If I said there are 2 cats, there would have to be 8 dogs. If I said there are 10 pencils, there would have to be 5 erasers. All right, next we're going to do some part-to-whole proportion problems. So in a pattern of rhombuses and trapezoids, there are 2 rhombuses for every 4 trapezoids. Camilla is covering a large board with the pattern. It can fit 260 trapezoids. We need to figure out 2 things. 1, how many rhombuses does she need? And then 2, how many total pieces does she need? So we can do this a couple of different ways. I'm going to write out a tape diagram first, where I know I'm going to be comparing rhombuses to trapezoids. I had 2 rhombuses to 4 trapezoids. So rhombuses gets 2, trapezoids gets 4. I can fit 260 trapezoids. So 260 has to be broken into 4 things. So 4 goes into 2 0 times, it goes into 26 6 times without going over, and goes into 25 times. So there's 65 in each thing. So if I add those together, 65 plus 65, it's going to be 130. So how many rhombuses does she need for the pattern? She needs 130. How many total pieces? I'm going to add those 2 things together because there's rhombuses and trapezoids, so put them together gives us 390. That's using a tape diagram. You could again do this without a tape diagram, or if I had done rhombuses to trapezoids, could have done 2 to 4 is equal to x to 260. This one would have been nice to do vertically. I could have just done divide by 2 to get x equals 130. That one probably would have been faster doing that method instead. Now you're going to have to do the same part here where I circled these and said we have to add them together to find the total. So there are 4 problems here. Go ahead, pause the video, and work these out. It says use tape diagrams. If you want to use the tape diagram, you can. If you want to just use proportions, you can do that as well. So there are going to be 2 answers for each question because you have a part and a whole that you are finding. All right. So number 1, art class has 2 different kinds of brushes for painting. They come in packages. There are 4 small brushes for every 3 large brushes. So I'm going to go small to large. There are 96 large brushes. Well, we went 4 to 3, 96 large brushes. How many small brushes are there? I can do times 32 to find that x equals 128. All right, so there are 128 small brushes. And, well, I had 96 large, 128 small. I want total. It's going to be 14, 12, 224 total brushes. That's number 1. Number 2, the class also has stacks of colored paper. They come in packages. For every 4 sheets of red paper, there are 5 sheets of yellow paper. So I'm going to be comparing red to yellow. We know there are 4 sheets of red to 5 sheets of yellow. There are 148 sheets of red. How many sheets of yellow? I'm actually going to get to use Y for yellow. That works out quite nicely. I want to go with the horizontal method. I don't know how 4 times what equals 148, so off to the side, do some division. Find out that is 37, so 5 times 37 is what I need to do. If I do that, well, 5 times 30 would be 150. 5 times 7 would be 35, so add those together, 185. There are 185 sheets of yellow paper and how many sheets are there altogether? 185 plus 148, that gives me 333 total sheets. Number 3, colored pencils for drawing come in large boxes. There are 2 colors of pencils in each box. We've got red to blue. We got 2 red for every 5 blue. We have a total of 135 blue pencils. How many red? What's the total number of pencils in the box? And I'm going to want to do this method. Horizontal, 5 times what equals 135? Well, if you don't know, divide. It's going to be 27. 2 times 27 tells me x equals 54. So there are 54 red pencils. And, well, 54 plus 135, 189 total pencils. And then we've got one more over here, number 4. Paints for oil painting come in tubes. A box of paints has 5 tubes of orange for every 6 tubes of dark blue. I'm going to compare orange to dark blue. Since it specifies dark blue, I should specify dark blue as well. We go 5 to 6. There are 84 tubes of dark blue paint. I don't know how many there are of orange paint. Vertical method is not going to work. Hopefully that horizontal method works. Let's divide 84 by 6 off to the side. And realize that we just multiplied by 14. So we've got y equals, well, 10 times 5 is 50. 4 times 5 is 20. Together is 70. Okay, if I also add 70 to the 84 that was total, so my answer would be there are 70 tubes of orange paint and 154 tubes of paint. I don't have to specify color there because I'm just saying all of the paint together. All right, so there was lesson 12. Make sure you go ahead and do your lesson 12 homework as well, and I hope everybody has a great day.